Okay, hello and welcome to this video about how to do calculations in work and power. Hey, what do wind turbines talk about? Nothing special. They just shoot the breeze. I thought that was appropriate because wind turbines generate power. Okay, by the end of this lesson, you'll be able to calculate work done given force and distance and calculate power used given work and time. All right, so in another video you saw the formulas for the two. Work, that's force over force times distance, right? So a force has to be applied to cause something to move a certain distance, and then to find the actual amount of work, you multiply the two. Power, on the other hand, that's work divided by time. So it's how much work we can do in how much time. We find work and we divide it by time taken to do that work, and we get power. And the units, of course, are here. Work is in joules, and power is in watts. Let's look at an example calculation. A 50 Newton rock is lifted 2.1 meters in 5.8 seconds. How much work is done? So for work, remember, we just need force and distance, right? So the force is 50 newtons, because that's the weight of the rock, and 2.1 meters, that is the distance that it went. And for work, we don't need to worry about the time. So here's how you do it. Work is force times distance. 50 newtons times the 2.1 meters. That's 105 newton meters, and a newton meter is the same thing as a joule. So your final answer, 105 joules. Okay, now, same question, but what power is used? We calculated the work in the previous question. Now we want to know what power is used. So power is work over time. How much work was done in how much time? So the power we calculated in the last question is 105 joules. And the time is given to us as 5.8 seconds. So 105 joules divided by 5.8 seconds. That gives us 18.1 joules per second. And joules per second is the same thing as watts. So 18.1 watts is your answer. Okay, now let's imagine a weightlifter lifts a 1,500 Newton barbell above his head from the floor to a height of 2 meters. He holds the barbell there for 5 seconds. How much work does he do during that 5-second interval that he held the weight above his head? So notice there's a couple of things happening here, right? He does lift this barbell, and then he holds it there, right? So in a competition, there's certain competitions you have to hold the weight up for a certain amount of time, I think. I don't know. But it says that he first lifts and then he holds there for 5 seconds. So we want to know how much work does he do during that 5-second interval. Well, the force was 1,500 newtons because that's the weight of the barbell. But the distance in that 5-second interval is 0, right? Sure, before that he did do work to lift it above his head, but while he's holding it above his head, the distance is not changing. So according to the formula of force times distance, it's force times 0 meters, so that gives us 0 joules. No work is done. And that's where it gets confusing, because in everyday life we think, well, they're working really hard. It's taking a lot of effort. But in physics, we only care about whether it is changing distance, right? Whether it's going somewhere. So the work is 0. Even though there's a lot of effort, the work is 0. But now let's see if we do have something where we calculate in the other direction. So we've got that weightlifter and he uses 2,000 watts to lift a barbell 2 meters in 2 seconds. So can we use that information to calculate the mass of the barbell? So we have a power amount, we have a distance, and we have a time. Can we get the mass of the barbell? So first, let's see if we can get the work out of this. The power is work over time, and we want to know what the work is, because we're trying to go backwards all the way to mass. So if power is work divided by time, 2,000 watts of power is that work divided by 2 seconds. So we multiply both sides by 2 seconds, and the weight then becomes 2,000 times 2, or 4,000 joules. So the lift was 4,000 joules of work. Now, let's try to get the force out of it. So work is force times distance, right? And we calculated the work in the last part as 4,000 joules. So 4,000 joules is the force, or essentially the weight of this barbell, times 2 meters, right? The distance that it was moved. So we divide both sides by 2 meters and we get a force of 2,000 newtons. So the weight of the barbell is 2,000 newtons. Now we need to calculate the mass out of that by using the weight equation. So you're seeing we can use multiple equations that have terms in common to get what we want. So weight is a force. So we calculated the weight as 2,000 newtons, and weight is equal to mass times acceleration due to gravity. So 2,000 newtons is equal to the mass of this barbell times 9.8 meters per second squared. So to calculate the mass, we have to divide both sides by the 9.8 meters per second squared. So the mass is 2,000 newtons divided by 9.8 meters per second squared, and that comes out to 204 kilograms. So 204 kilograms is the mass if he used 2,000 watts of power to lift a barbell 2 meters in 2 seconds. Okay, I hope that helped us learn how to do force, work, and power calculations. Let me give you a final reminder. Look carefully at whatever problem you're approaching and make sure that the force is being applied over a distance in order for work to be done, because sometimes the question is asking you something and it turns out there's no work actually being done. All right, thanks for tuning in. See you in the next video.